Greetings from sunny Scottsdale, Arizona. We are delighted to host this year's third annual Breakthrough Science Summit. We're so excited to host this year's summit in person, bringing together some of the leading minds from across the scientific, public policy, venture capital, and startup ecosystems. Last year, Prime Movers Lab published its first Breakthrough Science Roadmap, an interactive tool that allows you to explore the innovations that will happen between now and 2050. This week, we spent the last 2 days with some of the most brilliant thinkers and doers to review the roadmap and see how our predictions are shaping up. What did we get right? What did we get wrong? And what did we not even imagine? Today, we are coming to you live from the beautiful Omni Scottsdale Resort and Spa at Montelucia to dive into the top takeaways from those discussions and outline the research and policy breakthroughs that are needed to usher in a new era of scientific breakthroughs. And now, I'd like to turn it over to Prime Movers Lab founder and general partner, Dakin Sloss, who will introduce our live keynote with Heliogen and Idealab founder and CEO, Bill Gross.
Well, I'm so glad that we've got everybody here today for this exciting event, and really honored to introduce our first speaker, our keynote, Bill, and we'll be just having a discussion, and then there'll be time for Q&A. I think many of you know Bill, but Bill is probably the most successful startup entrepreneur on the planet. He's built and exited now 8 or maybe $9 billion companies, played a key role in inventing many of the things that we are familiar with Google, and has now dedicated his life to addressing climate change. And we're going to learn about some of the companies that he's working on in that area. Thank you so much for being here, Bill, with us today.
Oh, thank you, Dakin. Thanks for the kind introduction.
Absolutely. Just to start, could you tell us all a little more about what you and your team are working on at Heliogen, your primary focus?
Yes, well, at Heliogen, we're working to replace the burning of fossil fuels with concentrated sunlight. I think people don't realize that industry is pretty much the biggest user of energy and also the biggest polluter. But most of the energy they use is thermal energy. It's not electricity. And that thermal energy just comes from burning things. So if we can take the power of the sun to make that same heat, we can avoid that CO2. And more importantly, we can actually save those customers money. And money is a big deal for those customers because for cement, for steel, for minerals, basically their biggest cost is energy. So if you can save them money on energy and also avoid the CO2, it's a win-win. And that's what Heliogen's focus.
Fantastic. And you've done so many things over the course of your long career, transforming advertising, direct car sales, so many other industries. Tell us why you've kind of dedicated your life now to climate technology and why now is the right time for so many of these climate technologies, and maybe introduce us to a few of the other ones that you're working on in addition to Heliogen.
Well, I've always looked at problems in the world and searched for technological solutions to them. So there's many problems in the world that require other kinds of solutions, like either educational or legal or political, and I don't know how to solve those. But if a problem can be solved technologically, I get very excited. So I've often looked in my life for things that bothered me or things that needed to be fixed. And is there some angle, some technological angle that could address that? Well, today, the biggest problem facing humanity is powering the planet renewably. So if I can help find solutions to that, that would really make a difference to the world. And it turns out that energy is just embedded in everything around us. Energy is not only embedded in our transportation, in materials, but everything around us needs energy. And in fact, humanity has always been on a quest to have more energy. When we discovered that we could burn things, it was a boon for society and civilization. But if we need to power the planet sustainably, we have to find a way to get that energy without burning things. So I love working on this particular problem. It's purely a technological problem. It's really a problem about finding a way to use fewer atoms in the competition with fossil fuels, because fossil fuels are so cheap, you just dig them out of the ground and you burn them. So if you want to compete with those, you have to use every scientific trick there is, but the scientific method is a great thing and you can iterate to solutions to really make a difference. So I really love that.
Fantastic. Yeah, could you tell us a little bit more about the portfolio of solutions that you're working on right now to address climate change and kind of how you chose those set of problems?
Well, climate change is a big problem. The energy is the biggest industry on Earth. I think the GDP of the planet now is about $89 trillion, and energy is 10% of that, so $8.9 trillion. So to remake the entire energy business, to make an energy transition, of $8.9 trillion. It's staggering. No one thing is going to solve it. We need thousands and thousands of efforts to try and make an impact to change the whole society of the way we get our energy. So I have started a few companies in that vein, but I'm really trying to encourage more entrepreneurs to take what I call shots on goal, more attempts. But the particular things that I'm focused on are: one, replace the burning of stuff if you can, directly with sunshine. Another one is storing renewable energy. We have a company called Energy Vault, where there are lots of ways to make energy with solar and with wind cheaper than fossil fuels. But the problem with those is they're intermittent. And if you can hold on to that energy till the sun goes down or the wind stops blowing, then you really can make a bigger impact with them. So Energy Vault is a gravity storage system to address that challenge. There are also many sectors that are going to be very hard to abate, many remote locations or other transportation problems like aviation, other things that are going to be very hard to replace with renewable energy. And therefore, capturing the CO2 from those things is going to be valuable. We started a company called Carbon Capture, which is building a low-cost system to take CO2 back out of the sky and get it back underground, or turn it back into materials or useful things, so that we can avoid some of the really difficult, challenging problems. So those are just 3 companies in the mix. There are other ones we're working on, but I feel there are so many different opportunities. Really, what's happened in just the last few years is the effort to solve climate change has changed from being a problem to an opportunity. It became an opportunity when all of a sudden you could make money doing it. When all of a sudden you can help companies save money, it's no longer something that you need to do to try and solve a problem, but it's now really, really an explosive economic opportunity as well. So I think that's why so much money is flowing into it. And that's why governments are changing rules to flow even more into it to help us drive the price down. The incredible thing about fossil fuels is each amount that you dig out of the ground eventually makes it more expensive. But with renewable energy, each amount you make, the price goes down because we have a learning curve. There's no learning curve with fossil fuels. It doesn't get cheaper the more you do, but the more renewable energy you do, you can use all that learning. And of course, my big belief is using Moore's law as well, using computation as an angle, because computation is going down in price. So I feel all those things are powerful additives to make this an opportunity now that we've never seen before.
Awesome. Yeah. Could you dig in on what you were just saying about Moore's law and kind of why now is the time to be building generally breakthrough scientific startups, and particularly startups in the world of climate change, and what's really changed from the prior clean tech bubble?
Usually people think linearly. As human beings, we think about things that change linearly. Moore's law has made a change in computation, which has been exponential beyond our belief. So it's almost hard to comprehend, but I'll give you some examples to drive that home. In 1984, you could buy a gigaflop of computing power in a Cray supercomputer, a gigaflop, 1 billion operations per second. You could buy a Cray supercomputer that could do a gigaflop, and it cost $46 million. Today, you can buy a gigaflop, that same gigaflop of computing power, in a Sony PlayStation for 4 cents. So nothing ever in history has gone from $46 million to 4 cents in our lifetimes. So when you have something that goes through that great of a price reduction, and every other commodity never changes by that, you have beef, or you have coffee, or you have oil, they all fluctuate. They go up and down, 2 to 1, 3 to 1, 4 to 1, then they come back, but they never go down to zero. They never go down to cents from millions of dollars. So when you have something which is going down that fast in cost, you can harness that in other industries. You can use that capability to make other things less expensive as well. So I feel one of the great frontiers of civilization is to harness this fact that computation is almost free and always trending toward cheaper, even though it's already so inexpensive. Use that to solve a technological problem. So in our case, we use Moore's law to use more computer vision, to use more algorithms, to use more AI, to reduce the amount of atoms of steel we need and the amount of atoms of concrete we need, and basically using less materials and replacing with computation. But that can be applied to every sector. Moore's law is being used in biological studies. Recently, DeepMind was able to uncover all 200 million proteins on Earth by using massive AI algorithms to calculate that in a way that people didn't even think that was going to be possible. And that means that new medicines can be created. And Moore's law can be used in all forms of transportation, in agriculture, so many different places. So I really feel like this really is a frontier. It's great for science. It's great for opening scientific minds. And it's a new application that really we have to harness to make civilization sustainable in almost every fashion. And in fact, Dakin, I looked at the areas that you see between now and 2050, and energy, infrastructure, agriculture, transportation, manufacturing, life extension, health. Moore's law can be applied to every one of them. Every one of those can be enhanced with this power of computation. So I really feel like this really is a frontier. I think so many things have caused this to happen. Maybe it was computing, maybe it was gaming, maybe it was virtual reality, maybe it was even Bitcoin mining, which led to NVIDIA having all this extra processing power. But now that we have this processing power, civilization needs to harness it for good. And it's really, really a great, exciting time.
Well, I think it's hard not to get excited listening to you. Switching gears a little bit, you've started 150 companies, had quite a few IPOs and exits. When you're at that point of beginning a company, can you talk about the process you go through to decide what problems to solve and whether a company is really warranted in a particular instance?
Yes. Well, I like to think that we've gotten better at it, but it's still hard. Out of 150 companies, we've had 90 companies that succeeded, but we've had 60 failures. So we really learned a lot, probably maybe more from the failures than from the successes. But here are some things I can abstract from that. Well, one, you always really want to look for something that is an important problem, important either to the world or important to you, even to you personally. Now that the whole world is reachable, and that is a big change. When I first started companies, when I was a teenager, when I was in college, even when I graduated, the whole world was not reachable. You could reach your nearby audience, or you could reach the country through distribution channels, but you couldn't reach the whole planet. In fact, even go back further, go back to Leonardo and imagine the challenge that he had. A brilliant genius sitting in Florence, and his reach was the distance he could go by horse. So his ideas could only spread a very, very limited distance. But now you have the whole planet. So if you have a problem that's very personal to you, there probably are other people around the planet that have that too. And if you can find a way to cost effectively reach them, you can really make an impact. So finding something that's really meaningful to you and to other people is the first step. But then after that, you have to have something that has competitive differentiation. Business is very challenging. You have to have some bold differentiation, either protectable by IP or otherwise, or even if not protectable, still bold enough that people don't want to copy it at first because they don't believe in it, but you have to have some truth that you understand before other people do. So I really try and look at ideas that we have to figure out, is there really something that is different about this from the other way that people are thinking about it? And what evidence or what fact do we have that other people don't know yet, or people don't universally know yet? That's a very tough bar. A lot of ideas we come up with, we see a problem in the world, we see a way to solve it, but we just don't see something that we know about a way to solve it that no one else does yet. And we try to reject those ideas. Sometimes we fall so in love with them, it's hard to reject them, but we really try and use that as a filter. Next filter that we really try and use. Can we convince other people to join the idea? Can we convince people and money to join it? There was one point in Idealab's history where we had so much money from some of our IPOs that we thought we should just fund every idea ourselves. We were less successful when we did that than when we actually went out and convinced other investors to join alongside of us for multiple reasons. One is, of course, you want other people alongside of you to help you succeed. But the other one is, if you can't convince other people of your idea, maybe there's something wrong with it. And in fact, when you're pitching an idea to other people, you're learning something in every pitch. You're learning about the objections. You're learning about how to make the idea better. So I actually now embrace the pitch as a way to hone and refine both the story and the actual product. It's not just changing the story, it's changing the actual product itself to be more meaningful, more explainable, more understandable, and to explain the differentiation. So we look for all those things when we're first starting a company. If we pass those things, and of course we have to be in love with it. When you're going to go work on something for a big part of your life, you have to be passionate about it yourself. There are going to be tough times in every idea. Almost no idea just goes straight and up to the right. So having enough passion to persevere through those difficult times is very valuable. So I really urge ourselves and other people to look deep and say, do I really want to fight this one all the way through? It's like, do you want to go win the World Series with this one? Are you going to really do all the training and all the hard work necessary to win? And you have to feel that to be able to go forward.
Yeah, on this point, maybe you could help concretize that for folks with some of the stories of your own low moments that actually led to incredible highs and successes after persevering.
Well, I would say, I'll give you one example with Heliogen. I was really passionate about doing concentrated solar for a very long time. We started a company called eSolar back in 2007, 2008. that was doing a similar idea, but not as smartly. And we did not succeed. And when the company did not succeed, I was really, really disappointed. And I actually heard a talk from Reid Hoffman at a lean startup conference. And he talked about how, so I was sure I was not going to do something like that again because it was painful failure. And I heard a talk from Reid Hoffman. He talked about how LinkedIn was his third social network, that his first two social networks failed. And that on his third social network, he had a new idea. And that was, I need to get 1 million users quickly so I have enough density of usage. And he came up with the idea, I don't know if people remember back at the time, when LinkedIn first came out, it asked you to invite your whole phone book and your whole address book. And they had this idea that they could give you an incentive to invite your address book because it was helpful to you to have more contacts in the system as well. So they found a self-interest way to do that. Well, that got LinkedIn to 1 million users, and then LinkedIn took off after that. They made many other changes, but LinkedIn was a wild success for him. So listening to that gave me the following thought, which I hope could be helpful to other people. That each of your tries at something, think of it a little bit more like an at-bat. If you're going to go at-bat in baseball and you strike out, you don't quit baseball. You try and learn from that at-bat. You try and say, what was that pitch like? Which swing did I make that was bad? What can I look at the video and see what I did wrong? If you don't know anything and don't learn anything from that, maybe don't do another at-bat. But if you can figure out something that's different that you could do differently the next time, and that's what Reid Hoffman did. He figured out what he was doing wrong with his first 2 tries at a social network. Well, I thought about that and thought about that with respect to eSolar and then with respect to starting Heliogen. I said, what was wrong about what we did with eSolar? And I realized that what was wrong about what we did with eSolar is we weren't using Moore's law. We weren't coming up with a way to make our product lighter. We weren't embracing computer vision. We weren't using those technologies because I didn't know about those. This is back when I started Heliogen in 2013. But now I knew about those things. So I felt I know something now that I didn't know back then. That was number one. Number two, what else is different? Timing is different. The timing in the world of doing eSolar during the recession, there was a big recession in 2008. It really, really hurt us. Customers really dried up. I tried to evaluate, is the timing different now? Is there something new that I know and there's something different about the timing that makes starting Heliogen correct? So I really urge entrepreneurs to really look at the situation, to not give up, to even after a failure, maybe even consider again, if you have new information. You don't want to just go bang your head against the wall and do the same thing again. You're going to get the same results. But if you have something new, really to apply that. And I've applied that both at Heliogen and at Energy Vault and other companies where I've taken painful lessons, but really tried to say, now it takes a lot of, to say, have I learned something? It takes a lot of challenge to really honestly assess what went wrong. Because very often your first attempt is to blame other things or say it was outside my control or whatever. You really have to try and be really honest about the mistakes that you made and what you can do differently. And if you do that, I think it's really valuable to try again.
Awesome. Thank you for sharing all that. You've talked about how you said it earlier in this conversation, we need many, many shots on goal, maybe even 10,000 to solve the climate crisis. Can you talk about more of why you think that is and how you see that playing out if there are in fact 10,000 companies going after it, what the success rates will be and the implications of that?
Yes, well, first of all, the problem is so large, it's almost like you don't have to worry about competition. Of course, you always have to worry about competition. You have to have a differentiated offering. But here's an example of that. Humanity is emitting 40 gigatons of CO2 up into the atmosphere every year, 40 gigatons, 40 billion tons of CO2. So it's a huge, huge amount. If we want to avoid 40 billion tons of CO2 in the atmosphere, no one company can do that. No 10 companies can do that. So I divided that by a meaningful number, 10,000. If you divide 40 billion tons by 10,000, you get 4 million tons. So can a company avoid 4 million tons? The answer to that is absolutely yes. I'll give you one example. Carbon capture, one of our companies, just announced a project in Wyoming that will remove 5 million tons of CO2. So just to show you that one entrepreneurial venture has a chance to make an impact on 1/10,000th of the solution. Now, hopefully carbon capture will do way more than that and maybe do multiple projects. But I tried to break the 40 billion tons of CO2 in the atmosphere into a manageable bite-size amount that a single company could reasonably do and say, that's how many efforts we need. Now, of course, if one company is wildly successful, bigger than that, can do 10 times that, great. Maybe we need a few less. But that just shows you the magnitude of the problem and the magnitude of the opportunity. But 10,000 things means millions of people could go work on this. There's job creation like crazy. There's opportunity. We're remaking 10% of global GDP. And that just means that there's so many things that could be done. And there's really, really great, it's a great time to be an investor in this. I love that you're doing this, Dakin, but many people should be investing in this. I think this is the investment opportunity of all of history. I say of a lifetime. I'm going to go bigger than a lifetime. Think of the past investment opportunities. There was the crazy opportunity during the Industrial Revolution, the unbelievable opportunity during the PC revolution, the internet revolution, the mobile revolution. This one dwarfs all of those. This is bigger than all of those combined because this is energy that powers everything on Earth. So it really, really is a huge, huge thing. But that's why I say we need 10,000 things.
Yeah, just to emphasize that point for people, the number one greatest predictor of success for society and material prosperity is energy cost per capita. And when you're basically redoing the energy infrastructure of a civilization, we've not really done that many times in history.
Yeah, and again, looking at your list of 6 areas, which I love, 6 areas that are going to be impacted by 2050. If you look at those 6, energy, of course, infrastructure, well, that's energy. Agriculture, well, that's energy. Transportation, that's energy. Manufacturing, that's energy. It's just lurking underneath in every one of those. If we want to have flying cars or high-speed transportation, we need energy. If we want to have food for all, we need more energy to make. So it applies to everything. It's really, really incredible.
Awesome. Well, we're actually even starting to get some audience questions coming in. So if you have a question out there, please post those and we'll get to those shortly. You can just type them into the chat. For the next question I wanted to talk with you about, Bill, is there's been a lot going on in the policy world lately. You've had the Inflation Reduction Act, the Chips and Science Act. Can you talk about what impact those pieces of legislation are already having on Heliogen and carbon capture and Energy Vault, and really help people understand the detailed economic impact at this point? Because I think many people don't appreciate how fundamental of a shift it is for climate companies. Yes,
this new Inflation Reduction Act is a world-changing act. I'll tell you why. It's $364 billion, but it's actually not $364 billion. It's probably closer to $2 trillion. Here's why. And maybe it's closer to $5 trillion, which is an unbelievable impact on society. Here's why there's an Atlantic article recently that argued that it was 2 trillion. I'm going to tell you why I think it's 5. It's 2 trillion because, first of all, some of the things in the bill are uncapped. Some of the production tax credits for hydrogen are uncapped. Some of the other things are uncapped. So that really means that if we really go crazy and build out of this infrastructure that we need, it might be more than that number. But second, it's not just that they're uncapped, they're matched. Companies match to get that money. So the amount of investment that companies will be making alongside of that, companies and countries will be making alongside of it, multiplies it to much, much higher. Then other countries are going to start matching this. France has already talked about matching something like it. And Germany will, I'm sure, too, and other countries will. Why? Because otherwise all the innovations can only happen in the United States. The United States has just given a huge incentive to this innovation happening here, while other countries don't want to be left out. So globally, the whole world has woken up to the fact that we, especially because of what's happening in war and everything with energy, people are realizing that relying on things that you dig out of the ground, relying on a geological lottery is not going to sustain civilization. Relying on the fact that you happen to be in a country that happens to have the stuff you need under the ground doesn't work. Making something that's renewable and sustainable and transportable really is the way future will work. So if you make a green molecule like hydrogen that can be transported around the world, all of a sudden you can use the same methods we have of moving liquid energy around the world today to make energy where the sun is good or where the wind is good and move it to where it isn't. So you really have an unbelievable uniformity in getting that renewable molecule around the planet. So the shot in the arm that this bill has given is staggering. It all of a sudden makes carbon capture economic. As we drive down the price of taking carbon out of the atmosphere to be economic on a variable basis with companies, we now have government stepping in and helping us drive down the price. And of course, this is back to what we were saying earlier. There's a learning curve. Every time you double the cumulative production of almost any technology, it goes down in price, 15%, 20%, 25%, or 30%. It goes down from learning curve. So what governments are doing is helping that learning curve accelerate. This exact same thing happened for solar panels. Germany, other countries made subsidies for PV panels, which helped manufacturing drive down the price to where now PV panels without any subsidies are the cheapest electrons made in all of human history. So it works. Basically, we proved over 10 years that those things work to actually drive the price down so the subsidies are no longer needed. So this new IRA is a 10-year plan to do the exact same thing on much, much bigger technologies than just PV panels. That's why I'm so excited about it.
That's super exciting. Well, I'm going to turn to a couple audience questions now, and then back to some of the questions I have. To start, how do you think we get a new generation of kids interested in STEM and solving these big problems?
Oh boy, I think they are. Well, here's some things that I heard. I heard from admissions at MIT that 50% of every single new student coming to MIT wants to work on renewable energy or climate change or some climate impact. And the other 50% wants to work in robotics or AI or computer science or mechanical engineering to work on that to help climate change. So it's basically 100%. So I think that the efforts of activists around the world, Greta and others, have really educated youth to how big this problem is, and that youth, if they want to have a planet like you and I inherited when we were born, they really need to work on it. Now, I do think we need to connect the dots that the way to make an impact and work on it is a STEM education. So I definitely think we need to make sure that people know that is how you make that impact, that just holding up a sign and protesting gets the awareness, but doesn't actually make the change. But think about if we could take the million kids who were doing Fridays for Climate, striking on Fridays around the world, which I think Greta just had the 219th Friday in a row where they've been striking for climate around Europe and elsewhere. If we can take those same million people and put them in those 10,000 startups, just imagine how they could actually do something about it. So I really want to try and find a way to get that kind of movement to happen. But I agree with you. We have to have more clear connection that the way you can solve the problem is with that STEM education.
Awesome. Next question that we have is, what are your thoughts on the water energy nexus? Water is at the heart of all industries. It's obviously very important.
I think that with the recent things we've seen in the world is basically either on fire or in drought or being flooded. And in the drought and being flooded, it just shows the severity of how water is not going to necessarily be where we need it. And I would love to try and find a way to help solve that problem. I'm thinking of ideas, and maybe we can work on something together with you. They can do it. But I think that water is going to be a problem that, if not solved, will cause mass migration, famine, and political problems. So I think it is a very, very big area. We have to find a way to successfully use renewable energy to help with the water problem, and I hope to be able to contribute to that.
Well, knowing Bill and having heard that, there'll probably be a company shortly. Next, how soon does Heliogen start to scale with multiple customers around the world and multiple heliostat operations? You know, there's a couple customers that have been announced in the past few years, and this questioner says they love the company, but just want to be curious about the near-term growth plans, if you can share anything.
The Inflation Reduction Act has caused Heliogen to get way, way more excited about building right here in the United States faster versus looking for places around the world like Australia or Chile or South Africa, where we previously had been looking. So we are making plans to accelerate hydrogen production right here in the United States. We have a big site in Arizona. We've announced that we've procured 3,300 acres in Arizona where we could build a possible large-scale hydrogen facility. So we are looking to accelerate that. I can't announce anything about that right now, but believe me, with the IRA, it really, really makes America a great place to build these projects, and we're accelerating that.
Awesome. Another question is it possible, given the current state of technology, to replace fossil fuels without nuclear? And if we have a scalable and affordable carbon sequestration technology, why wouldn't we just stay with fossil fuels?
I think that to do all 40 gigatons and sequester all of that is too hard and too expensive. I think that we should rely on carbon capture and sequestration for the parts that we can't decarbonize. But basically, here's the way to think of it. Every amount of CO2 you want to avoid has a cost. And you want to go after the lowest cost method of avoiding it first. Well, the lowest cost method of avoiding it is just not to burn the fuel in the first place. That is absolutely cheaper than burning the fuel and then capturing the CO2 and then burying it. So for sure, we should avoid all the burning of fossil fuel that we can to start. And I do believe nuclear is a big part of that solution. I think nuclear should be scaled. I think the challenge that with nuclear has been twofold. First, there's been a perception problem which does not match the actual danger. Nuclear is the safest energy creation there is, but people don't believe that. So there is definitely a perception problem that needs to be fixed. But second, nuclear needs to be made more scalable. And the nuclear power plants that we've built in the past take too many years to permit and too many years to build. By making it more modular, by inventing new technologies around fusion and fission and all of those so that we can scale them more and faster and address the perception of safety, I think nuclear should be a very big part of the solution. It is, of course, 100% renewable. It doesn't release any CO2, and it really can, and it's stable. It solves the intermittency problem that other renewables have. So I really feel that's going to be an important part of the solution, and I think it definitely needs to be scaled. And there is investment dollars. There are investment dollars coming into it, and there are incentives in the IRA for that as well. So I think that's really going to be a game changer for people revitalizing this effort. It's very important. I know, Dakin, you're making investments in nuclear, and I think those are very, very valuable. I think it's going to be a big part of the solution.
Fantastic. The next question we have is, how often is public policy the hurdle to solving these big problems? And how often is it just because the tech isn't yet mature enough or doesn't exist?
I think public policy has a big factor in it. I think there are a lot of places where there's just straight misinformation. I'll give you the one example of nuclear being safer than people perceive, but I'll give you another example of politicians who, for some reason or another, for whatever their incentive is, say that by adding renewable energy to the grid makes your bill more expensive. It actually makes your bill less expensive. So we need to correct the misperceptions. Policy can help correct those. Policy that drives the direction of the way things are actually saving people money will correct that. And I think the IRA does makes a good step toward that. But we have a lot more to go. I can't get into the aspect of how money and politics causes some of that misinformation to happen, but it is a problem. Money in politics causes incumbents. This is true of all incumbents in any industry. Incumbents in industries don't want to be disintermediated. They don't want to be disrupted. So they will spend money with lobbyists. By definition, if they're an incumbent, they have a lot of money and they have a lot of lobbyists. So they fight hard for that misinformation to not tell the truth about bills being lowered or nuclear being safer or so on. So we really need to combat that. I don't have an easy solution to that. As I said to you before, I focus on technological solutions. I don't know how to do the political ones, but we do need people who do those as well. Like, just because I don't know how to do them doesn't mean we don't need them. We need education. We need laws. We need political solutions. Those are outside of what I do in startups.
Got it. Another good question here is, many emerging countries are developing and have high energy needs. How do we have them turn to cleaner sources of energy? What are the global markets that have the most potential for Heliogen and Energy Vault and many of the other companies that you're doing?
That's a great question, and there's a great opportunity there. Just like in the cell phone revolution, some of those countries skipped the wired line phase and went right to cell phones and went straight to mobile. And I think that some of the countries that have remote villages and remote workers and remote labor might be able to skip building a fossil fuel plant to power them and go right to distributed solar or distributed energy of some kind. By making it economic for them to do so, they will be able to do that. Just like the cell towers made it more economical than laying the wires, laying the fiber, laying the cable modems. So I feel that it's our obligation as an industry to make solutions that are easy enough for them to deploy and save them the money so they can skip the whole step of building the old infrastructure that we built here, the old centralized infrastructure that we built here and in the rich world. I really think that's a big opportunity. And I think it's not only a big opportunity for a business opportunity, I think it's a big opportunity to help people in those regions. Because energy lifts everybody. Energy goes to health, goes to education, goes to the water problem, goes to everything. So I really feel we can make life better for many, many people if we can give the technology to those countries so they can scale it in that distributed fashion.
Fantastic. Yeah, a related question I'm seeing is, can these technologies be applied and efficient on a smaller scale? For example, could a local town invest in these technologies to cover its energy needs?
I want to make that happen. I really want to make the module size required to make the economics work smaller so it can be deployed on a more distributed and more individually owned, almost like a co-op level basis. It's hard. It's hard to make economics work when you make energy small, but I believe we can get it down near the megawatt region, down from the 100 megawatt or gigawatt region. If we get it down to the megawatt region, then it can be applied in villages and remotely. And I really want to make that happen. It's challenging, but possible.
I think we've talked about with some of the things you're doing around motors and potentially around nuclear at some point in the future. There are other, big picture, I kind of think of this big map of the world where there's high DNI places where solar is going to make sense. There's places with great wind. There's places with great geothermal. There's remote locations where nuclear is going to make sense. And then you're going to have some amount of nuclear fusion that's just kind of baseload power distributed throughout. And that map kind of lays the future of what the next 30 years of energy reinventing is going to look like.
Yeah. One of the great things, if you can make something work at that smaller scale, is what you're typically replacing in those remote regions is trucked in diesel. And so not only is it highly polluting, it's highly expensive because you have to have a truck drive the fuel in. You're going to a place that almost by definition doesn't have a pipeline. So diesel's being trucked in on a dirt road. And it's really, really great to get rid of the cost of the trucking, the fuel used when you're trucking the fuel in, and the cost of that expensive, dirty fuel at the end. So here's the thing that's going in our favor of making a smaller modular system work, not just we, but anybody, mass manufacturing. So right now, people build huge power plants, gigawatt-sized power plants, which are long, multi-year construction projects. They get the economy of scale because the project is large, but they have the diseconomy of scale of all the infield labor, dealing with weather, dealing with all the permitting and all those issues. When you make something smaller, you don't quite get the economy of gigawatt scale, but what you get is you can make a factory, crank out all of them identical, and then just drop ship them in shipping containers to the end location. That's the way we get the price down of almost everything else in our lives, like our cars, like our iPhones, like our laptops. You could not make a car one at a time out in the field and have it cost anything near what a car costs. A car is an unbelievable work of technology that you buy for $10 a pound. Like that you could buy a car for $10 a pound with everything that's in there is unbelievable, but it's only because it's mass produced in a factory. I feel our energy needs to go more in that direction. And that's perfectly suited to renewable energy and not suited to some of the large scale projects that have been done in the past. You can't make a small coal plant that you can ship in a shipping container. That just requires too much other infrastructure, the steam turbine and all the stuff and the coal facility and all that. But you can make a renewable plant that fits in a shipping container. And that's why I think it's so valuable.
Awesome. We have a question about, should threats related to energy independence be prioritized as a national security concern in some way?
I really think so. I think that renewable energy is freedom energy. Basically, if you have energy that you can make on your own and not be subject to someone else turning off your supply, it is extremely more valuable than just the raw electrons. And in fact, I'll tell you, my first inspiration on energy at all was as a teenager. I was 15 years old in the 1973 energy crisis. And literally, I was riding my bike to school 8 miles because there's ration gasoline of only $5 a day. My mother couldn't get enough gasoline to take me to my high school. So I was riding my bike to school in the cold. I remember in the cold winter, that first year of the energy crisis, thinking, why is it that someone else can just decide to cut off our supply? And that's just sort of unfair. Like, why do we have a system that allows that, that enables that? It's because those fossil fuel resources are concentrated in only narrow locations around the world. So I remember going to the library and reading about alternative energy and what else could you do about that? Well, there's this thing that comes down from the sky, the wind and the sun, that everybody can use. It's way more evenly distributed. It's almost as evenly distributed as air. Obviously, there are some places that are sunnier than others, but only by a ratio of 2 to 1, whereas the oil concentration ratio is 10 billion to 1. So why not find a way to take that resource? And it is hugely valuable for energy security. I don't think we place enough value on that until there's a disruption. It's a little bit like everything. We don't worry about earthquakes until there's an earthquake. We don't worry about a flood until there's a flood. Well, look what just happened with Russia. We're about to see a winter where that pipeline is cut off out of spite or out of other objectives, and people will suffer. And I really would love to make a world where that suffering doesn't have to exist, where we can have that energy security and that doesn't have to happen. You take that card off the table. It'd be really, really great.
Yeah, I think that points to some of the things that for people who aren't necessarily as concerned about climate change, why renewable energy is promising. Can you also just talk about kind of where the raw economics are getting to at this point? So if you don't really have an ideological viewpoint of we need to address climate change, why are these some of the most attractive investment opportunities and some of the most attractive ways to just move humanity forward from an energy perspective, even if you put aside climate change?
Yes, it's just straight winning on cost. So the cheapest energy that we make in the world right now from burning coal or from burning gas is between 5 and 6 cents per kilowatt hour in a power plant. From wind power, we can get 3 cents, and from solar panels, we can get 2 cents. In some cases, at really large scale, even 1 cent. So people often talked in the old days about nuclear power being too cheap to meter. Well, PV panel power is almost too cheap to meter. It's so cheap. It's cheaper than anything else, not by a little bit, but by like a factor of 3 or a factor of 4. What is the problem? Education. We need to get people to understand that. What is the second problem? Implementation. We have to execute that at scale to do that. And then the third problem is energy storage, because we need to hold on to that energy for when people need it. Because right now, that solar power at 1 cent a kilowatt hour comes between 10 a.m. and 4 p.m. And what if you need power outside of that time? Well, that's where Energy Vault comes in. That's where Energy Vault and all the other 100 startups that are working on energy storage come in. It's why energy storage is so important. One more thing about that. Almost anything we make in life, it's cheaper to hold than it is to make. For example, you make an iPhone, it costs $1,000, but to hold it costs a penny. Like you could just hold it, hold on to it, store it, put it in a closet and hold on to it for nothing. Electrons are the opposite. Electrons are very cheap to make and very hard to hold. You have to use them as you make them. And that's why energy storage has to come down in price to make it almost as cheap to hold the electrons as it is to make them. The day we can hold on to the electrons for as cheap as we can make them, that is revolutionary. That's why I'm so excited about energy storage in all forms. That's where the real investment is. Right now, we don't have to worry about making the electrons cheaper. That's not the problem. We need to hold on to them cheaper. That's where Heliogen comes in too. With Heliogen, holding electrons is very hard, but holding heat is very cheap. Storing heat is very inexpensive. So what Heliogen does is gathers the sunshine during the day, but stores it in the form of heat, and then releases that heat as the industrial customer needs it. That is very easy. And that's why effectively Heliogen is an energy storage company too, just not storing electrons, it's storing thermal energy, which is very inexpensive.
Well, Bill, thank you so much for taking the time to answer all these questions from the audience, and thank you to the audience.
My pleasure.
For great questions. Is there one final thought you kind of want to leave us about the future and maybe why you're optimistic about where the world's going when there's so many reasons to get confused and pessimism?
Well, I think that it's hard to believe that all of us on this call would be alive in the exact decade when this transition is not only happening, but has to happen. Like in the whole history of humanity, there's like this 10-year window where we have to do this and where there's also this enormous opportunity. So if you take the brain power of humanity, brain power of the kind of people who are on this call, and put it to work to address these problems, I think the solutions are unlimited. And I think it's an exciting time to be able to take brain power and make that kind of difference in the course of civilization. So it is a really exciting time.